Good morning. Today we are working on our last objective of this unit. We're putting together what we've learned about opposite operations with adding and subtracting, opposite operations with multiplying and dividing. We're putting them together to be two-step operations. So we're going to be doing both those objectives in the same equation. So it's really important with this objective that we really listen to the steps. When we have the two steps, it has to happen in a certain order in order for us to get the correct answer. So this is, so often I say math can be done in many different ways and we can get to the same answer. With this objective, it has to be done my way. The way I show you is how we have to do it. And I want you to really, truly learn it because math in the future will build on this objective. If you don't do it the way that I'm showing you, could you still get the right answer? Yeah. But is it going to make math in the future a lot harder? Yes. I know what I'm talking about. I know what's coming. I need you to follow the steps as I'm showing it to you. Now, because my voice is going out, I don't know how the microphone's going to pick me up when I'm over at the screen. If you're watching this at home and you're having a hard time hearing me, you can look up last year's objective number CO43. It's the same objective. So if you have a hard time listening to the recording and you're not understanding it, look up last year's objective to help you. And then definitely come and ask me questions. All right, so CO43, I can solve two-step equations. Remember, I said when we're doing those opposite operations, we're doing something called SADMER. When we do normal order of operations, we do PERMDAS. We start with parentheses, exponents, radicals. Then we do multiplying or dividing. Then we do adding or subtracting. But when we do the opposite operations, we do it in the opposite order. We start out with doing the opposite of the adding or subtracting. Then we do the opposite of the multiplying or dividing. So remember, when we're doing those opposites, we do the same opposite to both sides of the equation. So we're going to work this through to see what that looks like. Solving an equation with two steps is merely building off the last two objectives and combining the two ideas. It's at this point that we move away from fact families, since there's more than one operation in equation, and because our equations are more complex, using logic alone is too difficult, right? So we have those three methods. You could ask the question, you could do the order of operation, or the fact family, or you could do order of operations. This is the point where we get down to, nope, we all have to do order of operations now, because there's more than one step. So we're gonna look at 5n plus 7 equals 32. In the equation above, we see there are two operations. That 7 is being added to the product of 5n. Because remember, when that number's right next to the variable, it's that invisible math. We know it's multiplying. And then we can see plus 7 is adding 7 to it. Sometimes we'll have that adding 7 in the front, and we would have 7 plus 5n. When we have the number at the front and it's just a number, we know in visible math it means it's a positive 7. Positive is adding. If it's a negative, negative is subtracting. So when that constant is at the beginning of our equation, look at that negative or positive and know that it means add or subtract. Okay. So, what is the opposite of addition, Michael? Subtraction. What is the opposite of multiplication? Fernanda?
Division.
Division. So if we see, good morning, if we see the addition or that positive sign, we know the opposite will be to subtract. If we see a negative number, we know its opposite is adding, right? Negative means minus. If we see multiplication, we know the opposite is dividing that number out. If we see division, we see that fraction bar, which we know means division. The opposite is multiplying. Here is where you need to be careful. When solving for a variable, there is an order that must be followed. You have to do it this way. We have to do the opposite of PERMDAS. We have to do SADMER. We have to work backwards because we are undoing the equation to solve for the variable. As when solving for any variable, plug your answer into the original problem. Follow the regular order of operations and see if it balances out. So let's look at that 5n plus 7 equals 32. And let's see how we work that out with our order of operations. What is our first step that we're going to do? Because remember, we're working with SADMER. What is the first thing that we notice? Haley?
You have to subtract 7 by 7 again.
Yeah, well, I just first, yeah. So, if we look at this, we need to look for any subtraction or addition. Haley saw that addition with that plus 7. So that means we have to subtract 7 from both sides. So plus 7 minus 7, 32 minus 7. We have to do it on both sides. Notice how I'm writing it right underneath. I'm not going over to the side and saying, okay, I know I have to do 32 minus 7. I'm doing it in an orderly manner because I'm going to be doing that funnel. I'm working my way down so I get n equals this number. We're doing that funnel down. 7 minus 7 we know is 0. 32 minus 7 is 25. That 0 I don't need to rewrite. We don't need to say plus 0. It's not going to change anything. So I'm going to bring down that 5n. I don't need to bring anything else down because we zeroed it out. I bring down my equal sign. I bring down my 25. Now, I'm down to the objective that we know. We just did multiplying and dividing with the opposite operations. So what operation is happening right here? When we see 5n, what operation is that, Rhoda? Multiplication. We don't see that invisible multiplication symbol, but we know it's there. What's the opposite of multiplying, Michael? Dividing. So I need to divide both sides by 5. 5 divided by 5 is 1. When I write my variable of n, I know that in front of those variables is going to be a 1, because 1 times a number, that number stays the same. So it's another invisible math. We know there's a 1 in front of that variable. We don't have to write it. Is it going to be wrong if you write it? No. But proper math, it's invisible. We don't see the 1. We just know it's there. So I'm just going to write n equals 25 divided by 5 is what? Rhoda?
5.
5. So now I'm down to n equals 5. I need to check my equation and see, does n truly equal 5? Do both sides equal out? So I'll have 5 times 5. I put it in parentheses because we know the number right next to the parentheses means multiply. So 5 times 5 plus 7 equals 32. So I'm going to multiply first. 5 times 5 is 25, plus 7 equals 32. 25 plus 7 is 32. 32 really truly does equal 32. So I know n really does equal 5. Let's work on the next one together. 2n plus 17 equals 25. What's my first step going to be? Remember, following opposite operations. What should I do? 2n plus 17 equals 25. What do you think, Jack?
Since there's a plus sign there, we should use subtraction and subtract 17 from 17 and 25 from 17.
I am going to subtract 17 from both sides because I was adding 17. I do the opposite on both sides. So now I'm going to, 17 minus 17 is 0. 25 minus 17 is 8. Now I'm going to rewrite my equation. I still have my 2n. 17 minus 17 was 0. I don't need to rewrite 0. And then I'm going to bring down my 8. So now, with my rewritten equation, I do it right underneath. Notice how I'm staying organized. This is going to be important in the future. Get in the habit of doing it now. You will thank me later. Okay? It should look like that. What step do I do next? What operation do we see happening? What's the opposite? Joy? Yeah, because 2n, we know means 2 times n. So now we have to divide. Because it's multiplying, I'm going to do the opposite. So I'm going to divide out 2. 2 divided by 2 is 1. So I can just write n, because 1n is the same as n. 8 divided by 2 is 4. So now I'm going to plug it back into my equation to see if I did my math right. 2 times 4 plus 17 equals 25. 2 times 4 is 8 plus 17 equals 25. 8 plus 17 is 25. And that balances out. 25 truly does equal 25. Let's look at our next one. 12n minus 5 equals 91. What is our first operation we have to do? What's the first step? I want you really looking at that, thinking, what is our first step? Let's see if we can get some more people brave to answer. Moses.
You add 5 to 5 and 5 to 91.
Yeah, because I was subtracting 5, I'm going to do the opposite, and I'm going to add 5. So, negative 5, because that minus 5 is the same as negative. That plus and minus stays with it, add, subtract, plus, minus. So negative 5, if I'm at negative 5 on the number line, and I add 5 to it, I get to 0. 91 plus 5 is 96. So I'm going to bring down my equation now. 12n, I don't need to bring down 0, and 96. So now I have 12n equals 96. What's my second step? What's the next step? Again, let's see some brave people raising their hand that I haven't heard from yet. 12n. Think about what operation that is with the 12 next to the n, and what's the opposite. Matt? It is 12 times n. So what would be the opposite of 12 times n? 12 divided by n, so I need to divide 12. So instead of multiplying, I do its opposite. 12 divided by 12 is 1, so I can just write my n. 96 divided by 12. What was it, pressing? 8. So let's now see, does n really equal 8? So we're going to put 8 in there for our n. So 12 times 8 minus 5 equals 91. 12 times 8, who has a calculator out? What's 12 times 8? Jackson? 72 minus 5. Jackson, do you have your calculator up? Do 12 times 8. It's not 72. 9 times 8 is 72. What's 12 times 8?
And
96. So if I had left it at that 72, 72 minus 5, 72 minus 5 is 87, or 67. 67 does not equal 91. And I would look at that and go, oh, wait, did I do my initial math wrong, or did I do my checking wrong? So I would want to recheck my math in my checking. Like I asked Jackson, you know what, use your calculator, what's 12 times 8? And that's where we found our problem. Sometimes that problem happened up here, because it's super easy to get our math facts wrong. To think, oh, I know this, 12 times 8, 72, got it, and just move on. And then you go, oh, snoikies, it doesn't balance out. 67 does not equal 91. Where did I go wrong? This is why we check our work to see and make sure that we're doing our math correctly. Now using 96 minus 5, we get 91 truly does equal 91. So we did do our initial math correct. One more on the top line here. 10n minus 9 equals 41. What's the first step I'm going to do? Remember that first step being the opposite of adding or subtracting. Michael.
You're going to add 9 instead of subtract 9?
Yeah, because I have a minus 9, I'm going to add 9 to both sides. So negative 9 plus 9 is 0, 41 plus 9 is 50. So now I bring down and I rewrite my equation. I don't need to rewrite the 0. 10n equals 50. Now I look at that and say, what operation is happening? What is its opposite that I need to do? So then what operation is 10n and what's the opposite? So I have a few people just kind of staring at me. I really want you to challenge yourself. What operation is happening with 10n? Joy. Multiplying. We know there's the invisible math of multiplying. What's the opposite of multiplying? Audrey? Dividing. So I need to divide both sides by 10. 10 divided by 10 is 1. 50 divided by 10 is 5. So I'm going to go back and check my work. 10 times 5 minus 9 equals 41. 10 times 5 is 50, minus 9 equals 41. 50 minus 9 is 41. 41 really does equal 41, so I know I did my math correctly. So that's doing our 2 steps when we have multiplying happening. Now let's look at our division. Our first one, we have n over 4 plus 13 equals 15. What's our first step we're going to do. Rhoda,
13 minus 13.
we're gonna subtract 13 from both sides. 13 minus 13 is 0, 15 minus 13 is 2. So now I'm gonna rewrite my equation, n over 4. I don't need to rewrite the 0. N over 4 equals 8. Now what do I do? Think about what operation is happening when we have that fraction bar. What's the opposite that we need to do, Moses? We need to multiply. If we're dividing by 4, now we're going to multiply by 4. Because 4 times n over 4 becomes 4n over 4. When I simplify 4n over 4, I divide those 4's out. And I'm left with just n. Because 4 divided by 4 is 1. 1 times n is n. 2 times 4 is 8. So I get my answer of n equals 8. I'm going to plug that 8 into my original equation. 8 divided by 4 plus 13 equals 15. 8 divided by 4 is 2 plus 13 equals 15. 2 plus 13 is 15. 15 really does equal 15. It balances out. Let's look at this next one. I might call on someone who hasn't raised their hand. So I really want you thinking about opposite operations. We want to do the opposite of subtracting or adding. We have n over 5 minus 20 equals 40. Think about what operation is happening. What is the opposite? Claire?
Add 20 to 20, add 20 to 40.
Yeah, we have minus 20, so that means we have to add 20. Negative 20 plus 20 is 0. 40 plus 20 is 60. So I'm going to bring down my n over 5 equals 60. Now I have n over 5. Think about what invisible math is happening there. So n over 5 is what invisible math, and what's the opposite? So what operation is happening when I have n over 5? Leo, what operation would that be? Yeah, that operation, that fraction bar means divide. So I need to do the opposite. Instead of dividing, I'm going to multiply by 5. So my 5 over 5 cancels out, and I have n equals 60 times 5 is 300. So you're going to plug that 300 back into our original equation and see if it balances out, if our answer truly is 300. We have 2 more problems left on here, and then we have our next page. The next page is a work page that is doing all the same math. We have specialist time right now. When we come back from specialist time, it will be work time. There will be questions, because we're gonna have negative numbers thrown in there. So we will have some questions. So I want to give us as much work. After specialist, we have testing. After testing, we will have work time. Okay? So if you are watching this at home, I hope you're well. Hope to see you soon. Have a wonderful day.